So another more theoretical video before we continue moving on with our mouse Theremin. I'm going to introduce you to the concept of open sound control, or as often called OSC. And OSC, open sound control, is a protocol, I guess that's what we call it. It's just a communication language, really. And it's often compared to MIDI. So MIDI is again a protocol, a type of language that allows things like keyboards and fader boxes and such to communicate with your computer. So it sends certain kind of signals, digital signals, and your computer's able to has a sort of a translator, a MIDI translator, able to translate that into things like pitch and volume and attack and such like that. Open sound control is essentially a lot like MIDI, but it's wide open, so you can send any kind of message you want using open sound control, and it's often used in these um, sound producing programs and such. It's a very sort of handy way to do things, really to add the sense of remote control to your instruments and patches, and it's going to be a key to this whole way of designing interactions in digital music. Basically, the idea is that within SuperCollider, we're going to create something that produces sound, something that sounds good. We're going to design a sound, really, do some sort of digital sound design. And then we're going to open up that designed sound, the instrument we made, to, to remote control or external control. And then in another program or within SuperCollider itself, or using physical devices, we're gonna we're gonna use those pathways, this OSC, this thing that's been opened up to us to control it. All right, so we have to sort of create the communication structure. We have to create this pathway, this thing to be able to control our sounds from various things. Okay, and it sounds a little, maybe I'm making it more complicated than it needs to be, but uh, in fact, it's quite simple, and we're just going to create a few little bits of code, kind of like little mini machines, little responders or listeners, and basically they're going to be looking out for an OSC message. They're going to just be a little machine that's ready to take in a message from the outside world through the network, through the internet, and then do something. Once it receives that message, a specific message, we're going to tell it which one. Once it receives that message, then it's going to perform some kind of action. Okay, very simply. So in this case, we want to be able to say change pitch and amplitude, and then also to trigger our our synth from the outside world. Okay, so what I'm going to do first of all is I'm going to. Sometimes it's a little bit problematic to just continue to use A. Actually, let me get my actual thing so we get something fairly close to it. I think this is the one. Right. And right, I do say MT. Okay. Right. Okay. So I'm going to call it MT. All right. So remember, single lowercase letters A through Z in SuperCollider are automatically what we call global variables. So this A will now be the synth, which will be recognized anywhere throughout. You can also create global variables using the tilde. So I'm going to call this tilde MT, and that'll be a global variable recognized throughout. And of course, if I want to do that, I'll change all these. But I'm going to get rid of all these sets because I don't really need them at this point. Okay. Now, what I want to do is I want to create these things called OSC defs. Okay, again, OSC all capitals and DEF, and just like all our other things, it has a scope there. All right, in these brackets. Okay, and then it has a number of arguments. You'll see it says key, function, path, and various other things. Okay, the main thing we're going to worry about the first three: key, function, and path. The key is actually not terribly important. It's just an identifier within SuperCollider if we want to change something, if we want to manipulate it, just as we do MT. So it's a name we're assigning to it to use within SuperCollider. So we're going to call this one, let's see, what did I call the first one? Well, we'll talk about pitch. We're just going to call it pitch. Okay, if we want to change pitch. So that's that backslash pitch. Okay, and then just like in the synth-def, the main things that happen within the function, these curly brackets. Okay, and then the third argument is the path. Now OSC uses a convention of this forward slash and then some kind of name. All right, so that's the actual name, and then this is a string, so we have to put it in quotations. That is actually the actual name of the message that's going to be this is listening for. So this little bot here, this OSC def, this function, this little bit of code is on. It's once we turn it on, it's going to be listening, and it's listening for this forward slash pitch. If it receives this forward slash pitch message, it's going to perform this function. It's going to perform that action. All right. So pretty straightforward there. So I'm going to give us a little room. I'm just going to put a couple hard returns, so everything in here is still within this function. That's where the most things happen. All right. So one more concept, and just bear with me here. One more thing that has to happen is within the functions. Let me just show you a quick example. Just like in synth-def, you have these args and variables within that function. You also have the same possibilities within the OSC def function. All right. Except in this case, there are already sort of predetermined, pre-slotted arguments that come in. All right. The first one is called message, MSG, I believe. You can also look at the help file. That's also very good. Oftentimes, it just goes straight to the examples. So you have message time, address, and receive port. These are the 4 automatic arguments. So you notice in our synth-def, we created these arguments. I made them up, gave them their names. Here, you can still do that, except the first 4 arguments coming in will be these 4, just because they're fairly important. So the message is in the format of an array, what we call an array, which is just an index list, and it happens in the square format. I don't want to get into too much now. You can look that up, or I'm sure there will be a video somewhere along the line talking specifically about arrays. But just so we understand that that's in that format, and it requires a certain way to deal with that. And that's all the information that comes with this message pitch. So if you want to send a bunch of data with that message, you're gonna craft an OSC message that says pitch, and then it's gonna have some data after it. In our case, we just really want one number. We want the actual pitch. We want a MIDI note number that comes in. Then that'll come in on the message. Okay. The next one is the time, so it timestamps it. Sometimes that's very important for syncing and latencies and different things. It'll tell the address it's sent from, and then the receive port, the port that you're receiving it on. Okay. You don't need to have all these, but that's the order, and the names, they come in automatically. So if I put message right here as my first argument, it'll always be just the message. It's the first thing. And that's the only one we need. We're going to use this argument message, and that's going to be all the things coming in. All right? And then we're going to perform some kind of something. Okay? So the main thing we really want to do now is if we want to control the pitch from outside, right? In SuperCollider, we would do something like this: mt.set, and then we'd say, what do we want to set? We want to set the pitch, and what is the value we want the pitch to be set to? Say 74 or something like that, right? And then they would change the pitch. We'd evaluate that and change the pitch. Now this is essentially going to do the same thing, except it's going to be done remotely. We're going to send a message, pitch. We're going to send some kind of value through the message, and then we're going to actually do this. So we can actually just copy that, because that's why in the previous video I wanted to explain how you manually set, because even though we're setting up a remote bot that's going to be doing these things, we're actually just asking it to perform the same sort of functions you would do within SuperCollider. So if we understand how to do it manually within SuperCollider, then we can also do it remotely, because we're just adding a few bells and whistles here that's going to essentially do that for us, but remotely or automatically or something like that. Okay. So we want to set a pitch, but we don't always want it to be 74, because every time it receives the pitch, it'll just play a 74 MIDI note, whatever that is. What is that? If 72 is C, that's D. It will always play a D. So in fact, we want to have it come through the message. Now, as I mentioned, a message is an array, and maybe I just very quickly show you, just very quickly, and we'll go over this, I'm sure, several more times. An array is this indexed, so I want to say C equals indexed value. So one, let's see, A, B, let's see, A, B, A, sorry, B, C. Okay, and it uses a square bracket notation. So if I do that, I have a index list or index set that's ABC. Okay, and if I want to call certain ones of them, if I want to call C, it's indexed from 0. So if I call the second value, which is B, I would say C1 in square brackets, and it produces B there. All right. So that's simply what it is. An array is this indexed list of values or data. All right. It's quite handy. There's a lot of things you can do. You can grow quite complex, but it's a good way of organizing sets of data. Now, I mention this because this message argument comes in as an array. All right. So it's a list of things. So basically, the very first thing that comes in, message 0, is this address, what we call the OSC address or the name. So it'll be pitch. And that's what comes in, that's what it's looking for. Message, and then everything after that will be whatever data is sent with that message. So if I send a big list of numbers or a number and a couple words or something like that, it'll come in on message 1, message 2, message 3, message 4. All right, so we'll have to remember that when we design the sender, which has come later on in this set of tutorials. When we design the sending mechanism, we'll have to just remember that when we send this message pitch, we're going to want to include one more piece of data, which is the actual number, MIDI note number of pitch we want to set it to. So we're going to set it to MSG1, because remember MSG0 is always this address that comes in. All right. So this little bot will do the same thing this does, except it'll allow us to do it remotely through the internet, and it'll allow us to have a variable to change the pitch to whatever pitch we want, depending on what number we send that to. Okay, so that's all, that's all there is really to that. Let me just quickly point out, and I'll probably mention this a couple times, that here I just was trying to save some space, so I put it all in one line. It's the same thing here. And this is just a shorthand in SuperCollider, these two things being arguments. So these are our arguments. It's the same as saying arg message. Okay, it's just a compact sort of way of saving some typing and a little bit of room in your code. So this is the one you downloaded and ran earlier, just to point out those differences. Okay, so we have an OSC def here that's going to set our pitch. As I mentioned, we want to do the same thing. So I'm just going to copy that. Once we understand how that works and once we've done it, we don't have to keep redoing it. We just copy it. We're going to change the amplitude to, we're going to make another OSC def or responder or listener or a little bot. And this is going to do the exact same thing. Except it's going to set the amp argument. And it's still going to be message 1 because we'll send the amplitude number through the message 1. Now, we're going to have to do trigger too. So we said trig, trig, and it's going to set the trigger argument. And it's still message 1. It's going to be either 1 or 0. Let's remember that. And we'll send it under trig. Like that. Okay, so just like that, we have our 3 OSC defs that will allow us to set remotely, allow us to set pitch, amp, or turn the envelope on and off. Okay, so let me get rid of these two, because really what we want to do, and I'm gonna and I'll show you how to organize things in just a minute, so they can be run kind of easily. We want to be able to do that from the outside world. Now, let me just show you how these OSC defs work. Once you evaluate them, they're running, and I'll just put a sort of a message dot post line. Okay, so I'm going to print the message that comes in for this trig. Okay, All right, so it says OSC dev trig and has these things. That just shows you that it's worked okay. Now I'm gonna just set up. You don't have to worry about this bit of code. This is just an example of setting up a sender here internally, just to send to myself, just so you can see how the trig works. So I'm gonna create an n equals net, and I'm gonna say it's 127.0.0.1. So 127.0.0.1 is the local host. That's just yourself. And the port name, I just go over this, but don't worry about it. I will, if we use this sending mechanism, I'll go over it in some detail at a later date when it's actually being used. Just to mention that the SC lang, this bit that we're working on, listens at 57120. That's the port number. That's the default port number. All right, so I'm going to send a message to myself through this end. I just get that going so it's a sender is available. I'm going to do n.send msg. Okay, and then I'm going to send the message. What did I call it? Trig, right? So just format it exactly the same way, and then let's send some data. We'll just send it the number 1. We'll send it a symbol hello. We'll send it a float 99.999. You can send really any loads of things. You can send it a function if you want. 1 plus 2, 3, whatever. You can send the supercompiler is good that way. It'll allow you to send whatever you want. Okay, so let's go ahead and send that over, and you'll notice that once it's listening for this trig, and once it gets this trig, it'll perform all these actions. One of which is just to print that whole message, and one which will set this thing that doesn't exist at this point. So it'll just kick an error saying that that thing doesn't exist. Okay, so there you go. We have it sent it. It's printing this MSG, and I told you it comes in this array format. So the first thing is the 0 is always the address trig, as I mentioned. The second thing, I know this is a bit small, but do your best, is just the list of data. So 1, hello, 99, and then it didn't have our function. I guess the function is, I think I have to format differently. I probably shouldn't have put that in there. Okay, but anyways, you get the point. So it sent all this data here in the thing, and you could, you can grab any bit of that data. If I just want to grab the hello, I'll just do it at 2, because it's the third thing. 0, 1 is this, 2th thing. Let me just reevaluate that. So now it'll only print. It should only print this hello, and there you go. It's printing the hello. Okay, so I hope that clears that up a little bit. I don't need any of this stuff here. All right, and I think essentially our MIDI, our mouse theremin, the generator, the sound generator, is essentially done. Yeah. Okay. So why don't I take? Well, no. Let me end this video here, and I'll make a short one about sort of cleaning things up and organizing them properly.